In previous lessons, a single data set usually contained all the data that you needed to perform a single business task. However, sometimes you'll find that the data you need is stored in multiple data sets. Using SAS, you can combine multiple data sets into a single data set. Then, you can reference the combined data set in your SAS programs. You can combine data sets horizontally or vertically. In this lesson, you learn to combine data sets vertically in several ways. In the next lesson, you learn to combine data sets horizontally. Here's what you learn in this lesson. When you combine data sets vertically, you place the observations from one or more data sets below or above the observations in another data set. In this lesson, you learn 3 methods of combining data vertically: appending, concatenating, and interleaving. To choose the best way to combine your data, you need to understand the structure and contents of your input data sets. To start, it's helpful to look at the descriptor portion of your data sets. For example, using Proc Contents or the Explorer window. To view the data portion, you can use Proc Print or the View Table window. When you combine data sets vertically, one of the most important questions to ask is, do the data sets have variables in common? Suppose you're combining data sets 1 and 2. You can see that the variables have common names. By examining the data further, you can make sure that variables that have the same names contain the same type of data. By examining your data, you might find that variables that have different names across data sets contain the same data. For example, suppose dataset 1 has a variable named last, and dataset 2 has a variable named last name. In this situation, you might want SAS to combine these 2 variables when you combine data sets. On the other hand, you might find that variables that have the same name in different data sets contain different data. For example, suppose both data sets have a variable named date. One date variable might store order dates, but the other date variable might store shipping dates. You would not want SAS to combine these variables if they hold different information. When you're combining vertically, it's easier to combine data sets that have identical variables. However, you can also combine data sets that have different variables. Now that you know the importance of understanding your data, let's take a closer look at the methods of combining data sets. We'll start with appending and concatenating, which are similar methods of combining data sets vertically. Both of these methods place the observations from one data set after the observations from another data set in a single data set. In both methods, the observations in the combined data set are in the same order that they were in each original data set. However, there are also differences between appending and concatenating. These 2 methods can have different results and different limits on the number of data sets you can combine at once. When you append, you can work with only 2 data sets at a time. Appending adds all the observations in the second data set directly to the end of the first data set. When you append, the first data set gets larger. You do not create an additional data set. Here's a situation in which you'd append data sets. Suppose you have a data set named EMPS that contains data about all employees hired in 2006 and 2007. Another data set named EMPS 2008 contains data about all employees hired in 2008. You want to add the observations for the employees hired in 2008 to the end of the EMPS dataset so that EMPS contains data about all employees. To do this, you append the EMPS 2008 dataset to the dataset EMPS. Concatenating copies all the observations from the first dataset and then copies all observations from one or more additional datasets into a new dataset. The original datasets are unchanged. Here's a situation in which you'd concatenate datasets. The EMPS-DK dataset contains data about employees in Denmark. EMPS-FR contains data about employees in France. Suppose you want to create a new dataset named EMPS-ALL1 that contains a copy of the observations in EMPS-DK followed by a copy of the observations in EMPS-FR. To create this new dataset, you concatenate the two datasets. When you append or concatenate datasets, the observations from each individual dataset remain grouped together and in the same order in the combined dataset. But what if you want to intersperse the observations in the combined dataset in a particular way? To do this, you can interleave datasets. Interleaving intersperses the observations from two or more datasets based on the values of one or more common variables. For example, suppose you are working with the datasets EMPS-CN and EMPS-IN. EMPS-CN contains data about employees in China, and EMPS-IN contains data about employees in India. You want to combine these datasets so that the observations are in alphabetical order by first name. To do this, you can interleave the datasets based on the variable first. Now that you've learned about three methods of Suppose you're working with EMPS, a master dataset that contains employees hired in 2006 and 2007. You want to update EMPS by adding the employees hired in 2008, 2009, and 2010. These additional employees are stored in EMPS 2008, EMPS 2009, and EMPS 2010, respectively. To add the observations in each of these three datasets to the master dataset EMPS, you'll append each dataset to EMPS. Here's a question. Do the three datasets that you want to append have the same variables as EMPS? Only EMPS 2008 has all the same variables as EMPS. EMPS 2009 has only two of the variables that appear in EMPS. But EMPS has a third variable that does not appear in EMPS 2009. EMPS 2010 has two variables in common with EMPS, and a third variable that does not appear in EMPS. Also, EMPS has a third variable that does not appear in EMPS 2010. In this example, and in all the examples in this lesson, you can assume that variables that have the same name have all other attributes in common as well. However, when you work with your own data in the future, you'll want to verify the attributes of the variables and any data sets you're going to combine. Also, notice that the data sets shown have only a one-level name, so they are stored in the work library. In this lesson, many other data sets are also stored in the work library. To start, you'll append EMPS 2008, the dataset that has the same variables. Proc append adds the observations from one SAS dataset to the end of another SAS dataset. You specify both of the datasets in the proc append statement. Base equals names the dataset to which observations are added. Data equals names the dataset containing observations that are added to the base dataset. In a proc append step, you can specify only two datasets. The example program shown here appends the first of the three datasets, EMPS 2008, to EMPS. Later, we'll write a separate proc append step for each of the other two datasets that need to be appended.
Now let's run the proc append step to append EMPS 2008 to EMPS. These two datasets have identical variables. Before we append the datasets, let's take a look at both of them. First, we open EMPS in the View Table window. Here's a question. How many observations are currently in EMPS? EMPS has 3 observations. Now let's open EMPS 2008. Here's another question. how many observations are in EMS 2008? EMS 2008 has 2 observations. When we add these 2 observations to the 3 observations in EMS, EMS should have 5 observations. Let's close the View Table window. Next, we write the proc append step. The proc append statement specifies EMS as the base equals dataset and EMS 2008 as the data equals dataset. Finally, let's add a proc print step so that our output shows EMS after the 2008 employees are added. Now we're ready to run the program. First, we look at the log. The log message indicates that EMS has 5 observations and 3 variables. Our proc print output shows that the 2 employees hired in 2008 were added to the end of EMS.
You should know 2 important things about how SAS processes proc append. First, SAS does not read the observations in the base equals dataset. Second, SAS cannot change any variable information in the descriptor portion of the base equals dataset. The way that SAS processes proc append does not affect your output if your base equals dataset and your data equals dataset have the same variables, like EMS and EMS 2008. However, if your input datasets do not have the same variables, your results are affected by how SAS processes proc append. Now, you're ready to append EMS 2009 to EMS. EMS 2009 and EMS share 2 variables, but EMS has a third variable that EMS 2009 does not have. Here's a question. How many variables will EMS have after you append EMS 2009? EMS will still have 3 variables. Remember that SAS cannot change the variable information in the descriptor portion of the base equals dataset. This means that the base equals dataset has the same number of variables before and after appending.
To append EMS 2009 to the base equals dataset EMS, which has an additional variable. Let's type our proc append step in the editor. Here's a question. What do we specify after the proc append keywords? After the proc append keywords, we specify the base equals dataset EMS as shown. Next, we specify the data equals dataset EMS 2009. Now we finish the proc append step. Finally, we add a proc print step so that we can see EMS after EMS 2009 is appended. Let's run our program and see what the log indicates. Now try answering this question. Did SAS find a variable in the base equals dataset that does not exist in the data equals dataset? In the log, a warning note indicates that the variable gender was not found in the data equals dataset. Here's another question. Was SAS able to append EMS 2009? Several notes in the log indicate that SAS did append the 2 observations in EMS 2009. EMS now has 7 observations. Now let's look at the proc print output to see what EMS looks like. Notice that the appended observations have missing values for gender.
There's just one more dataset to append to EMS, EMS 2010. EMS 2010 and EMS share 2 variables, but each dataset has a variable that does not appear in the other dataset. The variable gender appears in EMS, but not in EMS 2010. Also, the variable country appears in EMS 2010, but not in EMS.
Let's run a proc append step to see how SAS handles a data equals dataset that has an additional variable. This proc append step is similar to the previous ones. This time, we specify EMPS 2010 as the data equals dataset. Let's run this step. First, we check the log for messages that indicate how SAS processed the additional variable. The first warning indicates that the variable country is not in the base equals dataset. As you know, SAS cannot add this variable to EMPS. Here's a question. Was SAS able to append EMPS 2010? An error message indicates that SAS could not append EMPS 2010. However, the message also indicates that you can force SAS to append the dataset by adding the force option to the proc append step. The proc print output confirms that EMPS has not changed.
When the data equals dataset contains variables that are not in the base equals dataset, you can force SAS to append the observations by adding the force option to your proc append statement. You can place the force option anywhere in the proc append statement. The force option causes SAS to drop the extra variables in the data equals dataset, and then to issue a warning message in the log. For example, you can force SAS to append EMPS 2010 to EMPS and drop the variable country.
Now let's run our proc append step with the force option in SAS. First, we submit our revised proc append step. Then we look at the log. Notice that SAS still displays warning messages about variables not found in both datasets. Here's a question. Did SAS successfully append EMPS 2010 to EMPS? A note in the log indicates that SAS did append EMPS 2010, and 2 observations were added to EMPS. Another note indicates that the force option was used, so dropping or truncating will occur. Here's another question. How many observations and variables does EMPS have now? A note indicates that EMPS now has 9 observations, and it still has 3 variables. Let's look at the proc print output. EMPS has 9 observations, and the country variable does not appear.
You've now learned to use proc append in 3 situations. When 2 datasets have the same variables, when the base equals dataset contains a variable that is not in the data equals dataset, and when the data equals dataset contains a variable that is not in the base equals dataset. Take a minute to review the use of proc append in these situations. The force option is also required in other situations that are not covered in this lesson. To see a complete list of these situations, click Details. Now, try answering a few questions. Now, try practicing in your SAS software. Suppose you want to concatenate 2 data sets. EMPS DK contains employees from Denmark, and EMPS FR contains employees from France. In an output dataset named EMPS All1, you want all the observations from EMPS-DK to appear first, followed by all the observations from EMPS-FR. As you can see, these datasets have the same variable names. For this example, assume that the variables also have the same attributes. Concatenating EMPS-DK and EMPS-FR is straightforward because they have the same variables. In earlier lessons, you used the data step to create a dataset from a single existing SAS dataset, a Microsoft Excel worksheet, or a raw data file. In this lesson, you learn how to use a data step to create a dataset by combining multiple datasets. Depending on the statements you use in the data step, you can use it to concatenate datasets or to interleave datasets. In the data step, remember that the set statement specifies the input data. In the set statement, you can specify any number of datasets. You separate the names by a space, not by a comma. When you specify multiple datasets, SAS combines them into a single dataset. A simple data step with a set statement, like the one shown here, concatenates the observations from the input datasets. In other words, in the combined dataset, the observations appear in the order in which the datasets are listed in the set statement. In this example, the observations from EMPS-DK will appear before the observations from EMPS-FR. Finally, you can include additional statements that you might include in any other data step. For example, in the same data step, you could concatenate two datasets and use an assignment statement to create a new variable in the output dataset. Later in the lesson, you'll learn to add additional SAS statements to a data step. But for now, we'll work with a simple data step that has no other statements.
To concatenate EMPS-DK and EMPS-FR, which have the same variables, let's run our data step in SAS. Here's our data step. Let's add a proc print step to display the output dataset EMPS-all1. Now let's submit the program. First, we examine the log. Here's a question. Did SAS create the dataset EMPS-all1? A note in the log indicates that EMPS-all1 has 5 observations and 3 variables. The proc print output of EMPS-all1 shows that the 3 employees in Denmark are listed first, followed by the 2 employees in France.
Let's see how SAS processes the data step to concatenate the datasets listed in the set statement. During compilation, SAS reads the descriptor portion of the first dataset, EMPS-DK, and determines that it has 3 variables. SAS also determines the attributes of the variables. Then, SAS creates the program data vector, or PDV, with slots for the 3 variables. SAS then looks at the second dataset, EMPS-FR, to see if it has additional variables that must be added to the PDV. Here, EMPS-FR has no additional variables, so SAS makes no further changes to the PDV. At compilation, SAS also creates the descriptor portion of the output dataset, EMPS-all1. Now SAS is ready to execute the data step and create the data portion of the output dataset. To start, SAS initializes the PDV. This means that SAS sets the value of each variable to missing. Remember that SAS makes a pass, or iteration, through the data step for each observation that's read from an input dataset. Here's a question. Which observation does SAS look at first? SAS reads the first observation in EMPS-DK, the first dataset specified in the set statement. Then, SAS reads the values into the PDV. From the PDV, SAS writes the data to the output dataset as the first observation. Now, SAS returns to the top of the data step and reads the second observation in EMPS-DK. Because SAS is still reading observations from the same input dataset, SAS does not reset the values in the PDV to missing. SAS adds the second observation to the PDV and then outputs the data to the output dataset. Returning to the top of the data step, SAS now adds the third observation in EMPS-DK. SAS has now reached the end of the file. SAS reinitializes the PDV by setting all the values to missing. Moving on to the second dataset in the set statement, EMPS-FR, SAS reads the first observation. SAS reads the values into the PDV and then writes the values to the output dataset as the fourth observation. SAS reads and outputs each observation in the second dataset until it reaches the end of that file. SAS has now finished executing the data step and the output dataset is complete. In this example, you can assume that the variables in the two datasets are identical in all respects. However, when you work with your own data, it's important to verify the attributes of the variables. For example, if all the datasets specified in the set statement have a variable with the same name but different types, SAS generates a compile time error by default. To see an example that illustrates this error, click Details. Suppose you want to concatenate two other datasets that contain employee data. EMPS-CN contains employees from China, and EMPS-JP contains employees from Japan. Here's a question. How many variables have a common name across datasets? Only two of the three variables, first and gender, have a common name. You want to create a new dataset named EMPS-ALL2 that has three variables. As in EMPS-CN, you want the third variable to be named country, not region.
Let's run a data step to concatenate two datasets that have different variables. First, we type our data step in the editor. In the data statement, we specify the name of the output dataset, EMPS-ALL2. We want the employees in China to be listed before the employees in Japan. Here's a question. How do we specify the input datasets in the set statement? After the keyword set, we type EMPS-CN, a space, EMPS-JP, and a semicolon. After the data step, we add a proc print step to print the output data set. Now we run the program. First, let's look at the log. The log messages indicate that SAS successfully read the observations in the two input data sets in the stated order. Then, SAS created the output data set EMPS-ALL2. Try answering this question. How many variables does the output data set have? EMPS-ALL2 has 4 variables. Finally, we look at the proc print output. Here are the 4 variables, first, gender, country, and region. Notice that some observations have missing values for country, and others have missing values for region. This is not the output that we want.
Here's the output dataset that we just created by running our data step in SAS. Let's take a closer look at how SAS created this output. You'll see how SAS concatenates datasets by default when they have different variables. During compilation, SAS identifies 3 variables in the first dataset, EMPS-CN. SAS then creates a PDV with slots for the 3 variables, first, gender, and country. In the second dataset, EMPS-JP, SAS finds the additional variable region. SAS then adds region as the 4th variable in the PDV. SAS also creates the descriptor portion of the output dataset, which contains the 4 variables. At execution, SAS starts by reading the first observation in EMPS-CN. SAS reads the values of first, gender, and country into the PDV. But the observations in EMPS-CN have no value for region. Here's a question. What value does SAS assign to region in the PDV? SAS assigns a missing value. The data step executes once for each observation in both datasets until the output dataset is complete. This is not the output that we want. We want our output dataset to have only the first 3 variables. Also, we want to move the values in region to the country variable. To get this output, we can modify our data step to rename the variable region to country in EMPS-JP. To change the name of one or more variables, you can use the Rename Equals dataset option. You specify the Rename Equals option immediately after the associated SAS dataset name. Notice that you enclose the Rename Equals option within an outer set of parentheses. Within the Rename Equals option, inside an inner set of parentheses, you specify one or more variables that you want to rename. For each variable, you specify the existing variable name, an equal sign, and the new name. Of course, the new name must be a valid SAS name. If you are changing multiple variable names for the same dataset, you add a space, not a comma, between variables. If the Rename Equals option is associated with an input dataset in the set statement, as in this example, the action applies to the dataset that is being read. In our program, we want to rename a variable in the EMPS-JP dataset from region to country. The Rename Equals option does not rename variables in the input datasets. Instead, the Rename Equals option tells SAS which slot in the PDV to use when SAS is building observations in the PDV. Let's see how SAS processes our data step now that we've added the Rename Equals dataset option. During compilation, SAS creates the PDV with the 3 variables from EMPS-CN as before. When SAS looks at EMPS-JP, SAS sees the additional variable region. However, the Rename Equals option in the set statement tells SAS to treat the variable region as if it is named country. So the PDV and the descriptor portion of the output dataset have just 3 variables. At execution, when SAS reads the observations in EMPS-JP, SAS puts the values of region into the country variable.
Let's run our revised data step in SAS, which concatenates 2 datasets while renaming a variable. Here's our SAS program. We want our output dataset EMPS-ALL2 to have only the 3 variables first, gender, and country. We use the Rename Equals option to change the name of the variable region to country in EMPS-JP. Now we run it. This time, the log shows that the output dataset has only 3 variables. In our proc print output, EMPS-ALL2 looks the way we want it to.
In the data step we just ran, we used the Rename Equals option once in the set statement to rename one variable in the second dataset. Now, let's look at a couple of examples that use the Rename Equals dataset option in other ways. Suppose we want to rename the third variable in the first dataset, EMPS-CN, from country to region. In this example, we specify the Rename Equals dataset option immediately after EMPS-CN. The last example shows that you can use the Rename Equals dataset option for multiple datasets in the same set statement. Suppose we want to rename 2 variables in the first dataset, EMPS-CN, and 1 variable in the second dataset, EMPS-JP. Even though the first variable in the 2 datasets is currently the same, we want to change first to fname in both datasets. So, we specify this variable name change in the rename equals dataset option after both impscn and impsjp. In the first dataset, we also want to change country to region, so we add this to the rename equals dataset option after impscn. Before we continue with our data step program, as you've learned, appending and concatenating can generate similar results. In particular, when you combine two datasets that have the same variables, a proc append step and the set statement in a data step result in the same dataset. The only difference is that proc append overwrites the first dataset, whereas the set statement in a data step can create a new output dataset. Let's see when it's best to use proc append and when it's best to use the set statement in the data step. If you're concerned about speed, proc append is faster because it does not process any of the observations in the base equals dataset. The set statement is slower because it must process all observations in all input datasets. If you want to combine a large number of datasets, remember that you are limited to 2 input datasets in one proc append step. When you use the set statement, you can concatenate any number of input datasets in one data step. If you're combining datasets that contain different variables, proc append is more limited than the set statement. Proc append uses all variables in the base equals dataset. If the base equals dataset has variables that don't appear in the data equals dataset, proc append assigns missing values for those variables. And proc append drops any variables that are found only in the data equals dataset. The set statement uses all variables in all input datasets. If necessary, the set statement assigns missing values. To see a chart that describes these differences between methods in more detail, click Details. Now, see if you can decide. Now, try practicing in your So far, when you've combined datasets vertically, you've kept all the observations from each dataset together in the output dataset. Now, suppose you want to combine the two datasets, impscn and impsjp, so that the observations are interspersed. Specifically, you want to interleave the datasets so that the employees from both datasets appear in alphabetical order by first name. You'll call the output dataset impsName. You want the output dataset to contain the 3 variables that appear in impscn, so you'll have to rename the variable region in impsjp again. To interleave datasets, you use the data step. As in the data steps shown earlier in this lesson, you use the set statement to list the input datasets. The example shown here also includes the rename equals dataset option to rename a variable. Then you add a by statement and specify one or more by variables. SAS uses the values of the by variables to arrange the observations in the output dataset. Any by variables that you specify must be common to all input datasets or your data step will not run successfully. In this example, SAS interleaves the datasets based on the values of first. Remember that SAS arranges observations in ascending order unless you specify the descending option. Here's a question. What would happen if you ran this step without the by statement? Without a by statement, this data step would concatenate the two datasets, as we did earlier. Before you run a data step that contains a by statement, your input datasets must be sorted on the by variables. The datasets must be sorted in the same order that's specified in the data step, either ascending or descending. You want to interleave EMPS CN and EMPS JP by first name in ascending order. Here's a question. Are these two datasets sorted by first name in ascending order? Fortunately, these datasets are already sorted by the variable first in ascending order. We won't need to sort them. If you did need to sort the datasets, you could add 2 proc sort steps at the beginning of your program, as shown.
Now let's run our data step in SAS to see the interleaved dataset.
Let's take a closer look at how SAS
Here's the
interleaves
datasets with the
datasets
by
by
statement that specifies first as the by variable. Our program also includes a proc print step. We submit the program. The log indicates that our step ran successfully. These messages are similar to the messages we saw earlier when we ran a data step to concatenate data sets. The proc print output shows that the observations in the output dataset are listed in ascending alphabetical order.
Using a data step with a set statement and a by statement. In the compilation phase, SAS creates the PDV and the descriptor portion of the output dataset. Both have the 3 variables first, gender, and country. In EMPS JP, the rename equals option causes SAS to treat region as country. At execution, SAS looks at the first observation in each input dataset and compares the values of the by variable first. The by statement specifies that the observations be arranged in ascending order. Here's a question. Which of these 2 names should come first in the output dataset? In ascending alphabetical order, Chang comes before Cho, so SAS writes the values in the first observation in MCN to the PDV and then to the output dataset. In MCN, SAS now looks at the second observation and compares the name Lee with the name Cho in EMPS JP. Cho comes first alphabetically, so SAS now writes the first observation in EMPS JP to the PDV and the output dataset. Then, SAS moves on to the second observation in EMPS JP. SAS continues comparing values between the 2 datasets in this way until all observations are copied to the output dataset in alphabetical order. In this example, all values of the by variable first are unique. However, you might work with datasets that have duplicate values of the by variable. For example, 2 employees might have the same first name, as shown here. Here's a question. How does SAS decide which duplicate value to output first? SAS outputs the observations with duplicate by values in the order in which the datasets are listed in the set statement. If the duplicate values are in the same dataset, SAS outputs those observations in the order in which they appear in the dataset. To test your knowledge of by variables, now try practicing it. Here's what you learned in this lesson. Now, test your understanding by